Hi guys, today we're going to learn about index laws. And you might be thinking, well, why would I learn about index laws if I could sit on the beach and drink some nice juice, lie in the sun, or at least daydream about lying on the beach and watching the fishes jump around in the sea? Well, I tell you what, when you think about the Atlantic Ocean has a volume of about 300 trillion, or as the Americans would say, quintillion liters of water. Now that's a 3 with 20 zeros. To be honest, I'd prefer the notation of 3 times 10 to the power of 20 liters. To me, that's way easier. And as I might want to calculate something with that, I need to learn how to work with indices. So the first thing that we need to understand is that when we're looking at factors of one specific number, that's when we can use indices. Now let's look at an example. So what if we have 3 times 3 times 3 times 3 times 3? That's 5 factors of 3. So we can also write this as 3 to the power of 5. Now, let's look at the first index law, which is the law of multiplication. So if we have two terms with the same base and they're multiplied together, what we get, so in this case, let's look at an example. We have m to the power of 3 times m to the power of 4. And if we expand this, we get for m to the power of 3, m times m times m. And for m to the power of 4, we get m times m times m times m. Now, when we look at this long list of m's here, we realize that we have 7 factors of m. So we can write this as m to the power of 7. Now, note that 3 plus 4, which were the indices of our original expression, is equal to 7. 3 plus 4 is 7. Now, let's make a general rule out of this. If we have a to the power of m times a to the power of n, that is equal to m plus n. So the indices are added. Now, let's look at the second law of indices, which is the law of division. So, for example, if we have a to the power of 5 over a to the power of 3, the fraction line is nothing else but a division. If we expand this expression, what we get is a times a times a times a times a over a times a times a. Now, we can cancel several a's here. So we can cancel this a with that a, this a with the next a, and finally another a with that a on the denominator. And what we are left with are 2 factors of a. So what we get as a result is a to the power of 2 for that whole expression. Now note, the 5 and the 3 that we had as an index in our initial expression, when we subtract the 2, we get 2. So 5 minus 3 is equal to 2. Let's make a general rule out of this. A to the power of m over a to the power of n is equal to a to the power of m take away n. So we need to subtract the indices if we have a fraction given with the same base. And that's the general rule for division. Third law that we're going to look at is the law of brackets. Now, if we have an index like a to the power of 3 raised to a power of 4, for example, what do we get if we expand these brackets? We get a to the power of 3 times a to the power of 3 times a to the power of 3 times a to the power of 3. And now we know from the first law of indices, that was the first law of indices, that was the law of multiplication, that told us if we have factors of a to the power of something, we need to add the indices. So here we need to add 3 plus 3 plus 3 plus 3. So we get, as a result, a to the power of 12. Note here that when you look at the indices that we had in our original expression, they were the indices 3 and 4. Now, which operation between 3 and 4 gives us 12? 3 times 4 gives us 12. So let's make a general rule out of this. General rule. If we have a base a to the power of m to the power of n, that gives us a to the power of m times n. So the indices are multiplied. The indices are multiplied. And that's the general rule for dealing with indices that are raised to another power of something in brackets. Now that you have learned all about indices and index laws, you can take your time and enjoy your mental or real holidays on the beach. Have fun lying in the sun and thinking about your indices. Bye. See you next time.